We're doing it right now.
And that's the hydrogen, or is that just?
It's everything what we do. I mean, our boldest ideas we can't say now. Honestly,
Gotcha.
really. But I truly mean it. I'm one of the most fortunate people. We are some of the most fortunate people in the world to love what we do. And to be my son. Carter Lowrey. I'll do an Annalise Lowrey to my daughter. I can't not name drop her. I'll be in deep, what. But he asks me, and he says,
"Make sure they download the podcast."
That's right. I'm always talking hydrogen, natural gas, hydrogen emissions. And I love it. And he's like, "Man, wow, were you always so interested in the environment?"
Our mission, and we choose to accept it, is zero injuries and zero environmental impact. A healthy workforce and environment is key to our nation's continued success. The Mission Zero podcast is a deep dive with the industry's top experts into the health, safety, and environmental aspects of today's workplace. Our mission is to be a platform for new ideas and strategies that, when implemented, will improve our safety, our environment, and how we govern our business. We are making the world safer, and we're going to have fun doing it.
Okay, welcome everybody back to another edition of Mission Zero podcast. Today we have the Vice President and Director of Product Placement for ACT. ACT is a cryogenic equipment manufacturer here in Houston. Doing some pretty amazing things in that world. Also, I'll be remiss to mention I got Justin Overstreet being my wonderful co-host here today from Wildcat Oil Tools. Thank you for being here, Justin.
Thanks for having me.
And thank you guys for coming on board and letting us know a little bit about what you're doing and some pretty great technology. So
Absolutely. Thank you for having us.
Tim, I'll start with you. So everyone knows, I've known you for about 20 years now. So
it seems like longer.
Seems longer, but I've known Tim for 20 years, and this is it's great on both levels to have you on, man, because you have a guy that's out there building incredible things who's also you were in his wedding, and that's really cool to experience. So I'm really glad you're here. But we're here to talk about ACT. We're here to talk about the amazing technology you guys have, why it's promoting and furthering cleaner natural gas and how you're doing it safely. So real quickly though, before we get into all of that, Tim, if you could just give a little bit about your background, kind of what got you here and why why did ACT begin?
Mm-hmm. Absolutely. Well, once again, thank you both, Justin, Jeff, for having Adam and I on the show. Congratulations on the podcast.
Thank you.
It's excellent. We're definitely big fans, and we're excited and a little nervous to be here, but we appreciate it. As you mentioned, Tim Lowrey, Vice President of Sales and Marketing for Applied Cryo Technologies. ACT is headquartered here in Houston, Texas. We've got a 175,000 square foot facility located not far from Hobby Airport, as a matter of fact. And we employ just over 200 people. We're an equipment manufacturer, as you mentioned. We're really mobile cryogenic application equipment experts, if you will. The way I describe ACT is really definitely a collection of industry experts, but really an engineering firm with mass manufacturing capabilities. So I mentioned 175,000 square feet, 135,000 square feet of that is crane served. 95% of the equipment that we build is built in-house. We're vertically integrated. And when I say mobile cryogenic applications, that's liquid hydrogen, liquid natural gas, liquid nitrogen, oxygen, argon, and other cryogenic gases, ethane, ethylene. That's kind of our forte, and we manufacture tanks ranging from 500 gallons all the way to 50,000 gallons or more. And that's anything for storage and distribution of cryogenic gases. So that's stationary tanks all the way to liquid hydrogen trailers or liquid natural gas trailers. And then in addition to that, we're also really a turnkey system provider. And Adam will mention some of the projects that we've worked on over the last 9 years now. in the LNG industry. And as I mentioned, we're also, with hydrogen the way it is, getting more and more into the hydrogen economy and trying to build out that infrastructure. My role with ACT is Vice President of Sales Marketing. We've been incorporated since 2012, and I'm joined with my basically my right arm. Adam wears a lot of hats, but he's Director of Product Development today. That's right, and he runs the sales department with me. So Adam and I are there on the front lines, kind of the tip of the spear in the industry. Taking data from the customers, information from the market, and then designing solutions around that.
Okay, so 9 years ago, ACT was formed 9 years ago. Okay,
right.
Adam, a little bit about yourself, a little bit about your background.
Sure. So I got into cryogenic equipment manufacturing as a mechanical engineer about 15 years ago, and my background from that was I kind of gravitated into the thermal fluid side of my field. So I was doing a lot of process design, getting into the sales side of it as well, designing and selling equipment for customers, coming up with solutions. Met these guys about, maybe 10 years ago or more. And we were collaborating on a lot of different types of projects. And I really found a huge opportunity with ACT. So shortly thereafter, I started working for them. And shortly after that, I made the move out to Houston from where I was living in California. So going to school at Cal Poly, our philosophy was learn by doing. So that's a lot of what I carried to the team.
Fantastic school, by the way.
Yeah, thank you. Yeah. Not a lot of people know of the Pomona campus, but
plus the weather out there is just terrible. So getting here to Houston,
a big welcome.
Well, thank you, and thanks for having us on the show. I do appreciate it.
Well, great. If you guys, I would like you to talk a lot about, about what you do, exactly what you're building. That obviously we just heard from Tim. There's a service aspect to that as well, right? You're not just building things. First question: give us a rundown of what would be your primary product is. I'll let either one of you answer that question, and also remember in your engineering brains, the audience is not all engineers, so try to keep it as as a layman as you possibly can. But whichever one wants to go ahead.
I'll let Adam kick off on the LNG side, but I'll say that I'm not an engineer, so I'll dumb it down for all of us. Don't worry.
Sure. So cryogenics and what everybody thinks of as freezing heads, but what it really boils down to is shrinking gases down to a liquid state so that you can move more molecules in a greater payloads.
More economical.
So it's more economical. In the case of industrial gases, you're using liquid plants that are taking air and liquefying it. In the case of LNG and hydrogen, you're taking those gases and liquefying them by cooling them. So you cool them down to the point where they liquefy at an atmospheric pressure, and now you can store it in a cryogenic tank that is super insulated, much like the new thermos bottles that everybody's familiar with. They're vacuum insulated, and you're storing that thermal energy there so that you can then transfer that. And our focus is mobile equipment, like Tim said. So cryogenic transport trailers are predominantly what we build. And that's basically taking liquid from an on-site tank where they're producing it and hauling it to either a distribution point or a point of use.
A good example of that, I'll jump in there, would be like liquid oxygen with COVID. Everybody sure had a very challenging year last year and continue to do so with things related to COVID. Well, obviously hospitals in need of oxygen. So many of our customers, we serve the industrial gas industry. Your major gas suppliers, Adam mentioned the air separation plants where they'll literally take the molecules out of the air and then cool them down and separate those and turn it into liquid oxygen or argon or nitrogen. So the oxygen side of our business last year and continues to, this year was extremely busy, whether it be on the new production side or the repair side. We also own a pretty extensive repair and refurbishment department at ACT. So
who are your customers for the oxygen?
You like your Air Liquides, your Matheson Tri-Gases, your Air Products, Messer.
But what was the connection?
Linde.
Why did it pick up last year? Maybe I'm missing something there.
Oxygen for hospitals.
Right? So close to hospitals were the
the demand for oxygen was up. So you go to hopefully we don't go to the hospital too often, but when we go or drive by one, you'll see large vertical cryogenic tanks. So we manufacture those style of tanks, and then the trailers that deliver the liquid oxygen in cryogenic form will then fill those tanks, and then those tanks are hooked up to the hospital distribution network.
Nice.
When you guys are manufacturing those vessels, are there specific standards that medical grade gases have to be, the vessels have to be manufactured to for medical grade gases versus just your standard, maybe beverage grade or industrial grade gases? Is there a certain standard for that equipment that has to be met, or is it pretty much across the board same thing?
No, there is. The material of the inner vessel plays there's requirements around that for medical grade, and then it's really your O2 oxygen cleaning procedures for that inner vessel. So there's different processes in place throughout the production process where the different phases of production take place, where certain cleaning takes place of the inner vessel. So that's where that would come into play in regard to that.
Generally, oxygen as a component itself is so volatile that you have to follow these industry standard oxygen cleaning procedures because it will react with any kind of lubrication or grease or anything contaminant particulates that's left in there. Any source of ignition will cause it to ignite. So aside from being medical grade, it has its own safety caveats that you have to take into consideration. So that's kind of a general blanket spec that covers most of the uses that you would see. Now, for the oxygen itself, that does have a separate set of specifications for medical grade. Right. So the purity level and such.
Well, that's cool. A lot of companies pivoted to help the crisis we were in last year, and that's really great to hear that you guys were able to do that as well.
We just woke up in the crisis. It was
very cool. But let's just say times are normal. Who is your biggest typical customer? What are you building for them, and what your typical customer?
Well, without mentioning any particular customer,
I mean,
industry. Yep, I gotcha. It varies. Industrial gas is a huge part of our business. Liquid at the LNG part of our business is huge, especially over the last 12 months. Kept Adam very, very busy. So I would say those two, and then hydrogen. The hydrogen, I call this the decade of hydrogen.
Why?
I don't know if you watched the president's address. I think it was last night, but I don't know the exact number, but it's a $1.2 trillion spending plan, or I get lost after $1 million, but a lot of money they're going to be spending on clean energy. The Paris Climate Accord, the U.S. is back in that. So there's a big push from the administration and geopolitical pressures
and private funding as well,
and certainly private funding to come up with and to develop hydrogen infrastructure. So ACT is playing a major role in that. And
very cool.
Hydrogen is a cryogen, right? So that's right within our wheelhouse.
So that's the reason why that put up my spidey senses is, David Reed, the VP of Marketing Technology from NOV, was here, and he mentioned that, and it caught me off guard because it's not real. Or I guess before the president's speech, I don't know if he mentioned hydrogen specifically, but it hasn't been hugely in the news or any kind of reading I've done. But it's kind of that's the second time I've heard it from behind the scenes people. So that's another one that's coming, right? The big money is now behind
absolutely,
it's behind these things.
Oh
right?
yeah. You see it from so many different angles. The money is behind it.
So you're building these tanks. It sounds like there's about 8 or 9 different types of things you're compressing and freezing to travel across the country.
And just a point of, sorry to correct you. Normally I wouldn't do that on your show, but compression, we're cryogenics, and there's a big difference.
Okay.
Really. We're not compressing the gas; we're liquefying it.
Okay.
Compressed gas goes down the road at extremely high pressures relative to what we build, right? Our
thousands of PSI versus a few dozen PSI.
Right.
Yeah.
That's right. So
Great.
It is different with cryogenics. To Adam's point earlier, you're able to transport it more economically because I have the hydrogen number in my mind. The ratio, it's 850 to 1, right? So think of, the the liquid that you could hold in a ping pong ball would take up the mass of a beach ball in its gas state, right? So it's a significant difference.
So transporting would be impossible without your equipment, right? Or nearly impossible.
It's nearly,
in cryogenic
it's
form,
much,
right.
much more economical to haul in liquid form.
Okay.
That's generally the case.
And most of the tanks are there for road tanks, right? They're transmodal. They're on the highways.
That's correct. And we do what we call mobile storage units, or what we call industry term is a queen storage unit, which is basically a mobile vessel that's oversized such that its empty weight is near the max gross vehicular weight allowance. So you basically can move it empty, but then you can park it at a location and use it as a mobile storage customer station, if you will.
So it's a portable storage device.
Yes,
exactly.
And then we also do stationary storage tanks as well.
Okay, and to go back to this being this podcast is focused on safety, it's focused on environmental and all these things. One thing that comes up, and I guess it was a topic that did come up along with the Keystone Pipeline, right? That people are concerned with safety, they're concerned with the environment. Is this thing going to break? Is it going to leak? In reality, being around the oil industry as much as I am, I know it's safer. The Keystone's actually safer than most other modes of transport.
Right.
If someone was to ask you the question, what aspects of your tanks, what makes them, I guess nothing's immune to anything, but what makes them safe, in the case of accidents, and, we can't help that on the roads, right? If in case of an accident, in case something like that, what are the designs that you put into this product or this tank to make it safe?
Well, the Code of Federal Regulations is kind of the Bible for anything that's going over the road.
DOT, ASME, vessels.
Known codes and standards for equipment based on the experience and history that we've had and collected, on all the safety related to generate the requirements for how these mobile storage and transport units are manufactured. So there's a lot that can be gleaned from that. Obviously, we have our own proprietary and specific ways of doing things to protect it. But basically, you have fireblock valves on tanks hauling flammable liquids, so that if any piping was sheared off, there's automatic valves that can be manually or automatically tripped to shut off flow, so that nothing else is coming out of the tank and leaking all over the place. One of the other points, just a general safety term, as far as cryogenic fluids, is that you don't have any spills. Anything that comes out is going to evaporate and disperse in vapor form. So it will transfer heat from the surrounding environment into the fluid, and it will all boil off into vapor and evaporate. So that's one of the benefits of these liquid fuels.
So a drawback to that, though, could be like oxygen displacement, though. So if you had an incident that was in a not a confined space by definition, but in a building, if you had something shear, you could have oxygen displaced sufficient enough that it could create an unlivable atmosphere. So
absolutely,
obviously that's something to consider as well, right?
Certainly, and that's absolutely correct and a great point. All of our equipment is outside, right? So it doesn't mean you can't have instances where you'll have a collection of gases where whether it be nitrogen, right, where it can literally remove all the oxygen right up in front of you and you pass out. So all kinds of dangers related to handling cryogenic gases. But from an over-the-road standpoint and, impacts, anything from a side impact guard, which we've done for some customers, and then Adam mentioned the fireblock valve. It's a pretty cool piece of, I've always thought it was a neat piece of technology. If there is a fire, there's a fusible link inside this fire block, and it's just what it sounds like, a fire block, right? There's a penetration going into that inner vessel where the liquid's stored, and that valve will fail closed to basically keep it contained inside the tank. And then if you, as Adam mentioned, it's like a thermos or a Yeti cup, if you will. I'm not sure if they sponsor the show just yet, but they should. But it's just a big ass thermos, right?
Yeah.
So if you have some, crash into the side of that outer vessel and you lose vacuum, which we can maybe touch on here in a moment, but a thermos it's a vacuum jacketed thermos. that liquid starts to boil. Well, we're an ASME certified facility, right? So, a pressure vessel is a bomb.
Real quick, just for the audience, what is that? ASM. Go ahead.
American Society of Mechanical Engineers.
Okay. Right.
Go ahead. No. Go ahead.
Right. So the design of our bottle and the vent stack that comes out of that bottle is designed to where if you have a catastrophic loss of vacuum, which will then result in the liquid boiling, turning into a gas, expanding back to that, up to 850 times. It's got to go somewhere, right? It's got to go out that vent stack. So our vent calculations are designed and engineered for that very instance.
Yeah, and with that expansion, you could get blevy or whatever, right? So a huge cloud that just ignites spontaneously and consumes everything in it.
Right, and many of the gases are lighter than air, so they will naturally rise. Especially in any kind of outdoor environment. Some that are heavier that will kind of lay in blanket low to the ground, but not the case with hydrogen or natural gas. So liquefied natural gas and liquid hydrogen would both evaporate and go up.
So you guys have been doing this for 9 years, and it's now we're starting to see really the revolution, right? We've been told that the next generation of energy is coming. We've been telling it for a long time. It's coming now. Mm-hmm. You may know, you may not know, the United States is actually, the emissions have been lowering for a long time now. Know that. And I don't think the general public does. Like, not everyone listening will.
Right.
You guys are in the natural gas business. What is the exact difference? Why is how much cleaner is natural gas? Is it can you define that a little bit?
Sure. I mean, as a fuel source, it's roughly 30% less pollutive than any other diesel, gasoline, petrol-based fuel. And in addition to that, there's a huge cost savings to use natural gas as well. I think a lot of people misunderstand it. And in fact, I've read quite a bit regarding its contributing a majority of the benefit in carbon reduction over any other technology. Mm-hmm. So worldwide. So, the fact that it's abundant renewable and we're able to economically use it as a bridge fuel to get to this next step where we're going to this zero emission,
right?
It just makes so much sense for our customers who are out in the middle of nowhere running off of a propane tank or running off a heavy fuel oil tank to switch them over to LNG. And it's kind of a hard sell to get someone off of what they're familiar with. Mm-hmm. But you're also fighting at two fronts because you've got all the regulatory side trying to kind of suppress it because they view it as a fossil fuel. They don't like it. They just kind of chalk it up as another contributor, and then they give another black eye to it with regard to fugitive emissions. And that's something that I could expand on now. We could touch on it later, but we do a lot to make sure that we don't have any fugitive emissions.
Can you define that?
Yeah, exactly. What I mean when I say that is leaks, basically venting or even intentional venting. So some cases, you'll hear stories of somebody pulling off on the side of the road because their tank pressure is too high and venting the gas. That's not the type of practices that we follow or want to promote. We seek to do everything in the opposite direction, recovering vapor out of the tank. So if a tank's sitting for too long, your drinks in your thermos bottle, it'll stay cold for a day. You leave it there for 3-4 days, it's probably going to get warm. Mm-hmm. Same thing with these cryogenic tanks. You leave the fluid in there long enough, it's going to start to build pressure because it is now warming up to the point where it wants to be a gas again. So it starts forming a big gas pocket in the top of the tank. And then as time goes on, that pressure starts to build. And we have some different means of recovering that vapor using that gas, for either storage and reuse or putting it to some other purpose. So that's just one of the ways that we reduce fugitive emissions, and there's a lot of others.
That's a good point. A nice segue. The construction, just to explain to the audience, very few people have seen inside a cryogenic tank. People have been in the cryogenic industry for 30 plus years, and they've never seen the inside of a tank. We get to do it every day, and just to try to, I guess, articulate what that looks like. It's an intervessel stainless steel. Comes in as flat sheet or plate. We'll roll it, we'll tack it, we'll start to weld those pieces together to form the shell. Put the end caps on, or the heads, if you will, create the inner vessel, and then we'll super insulate that. We'll wrap that with super insulation is a combination of paper and foil. It looks just like what you'll see in your kitchen, slightly different, but not much. And then we'll wrap that. Depends on what it is, and it could be anywhere from 30 to 60 times. Just depends on the size and the type of equipment that we're building. And then at the same time, we're manufacturing the outer vessel, part you hold with your hand on the thermos. Mm-hmm. And then we'll super insulate the inner vessel. Then we'll nest that into the outer, and then put the outer heads on. And then we'll put a vacuum pump over there and pull the vacuum out. So think of it like, we call it the annulus space, or that void space in between the inner and the outer. And there's a bunch of molecules in there running into each other, and you clap your hands a lot, you start to get that heat. You're pushing molecules together. So we pull those molecules out because we remove the medium for heat to transfer to that inner vessel. So Adam mentioned we put, you have your drink filled up day one, it's cold, it starts to warm up. As it warms up, it's turning into gas. It's inside a pressure vessel. Ultimately they're designed to vent to atmosphere so that you don't have a bomb in your hands, right? Mm-hmm. They're designed to do that. But there's no mechanical necessarily. Sometimes there is, but 99% of the time, there's no mechanical process to keep that liquid cool. We're just protecting the temperature of the liquid. So that super insulation works as a way.
Those are radiation barriers.
As a radiation barrier.
So you have, right. You have heat that could conduct through the materials. By pulling the air out, you're making it a vacuum. It's like outer space. The only way that heat's going to move through outer space is radiation, which is light waves of different spectrums, right? So the radiation barriers are the foil and paper layers that prevent any of that radiation energy from coming in.
And I've seen it. It's impressive. It's it is a layered and there's a lot of parts to this, and I've seen it. I've been lucky enough to see the process of them being built, and seeing all how you kind of just said it's a tank inside of a tank, really. Mm-hmm. So brings me to a question. If I were to shoot the tank with a gun, what happens?
Most likely nothing.
The most Texas question you could ask.
Yeah.
Everybody wants to know.
It's a fantastic.
Everybody wants to know.
We've had enough experience.
Are the movies real?
Doing repair with units.
Terminator 2.
That's my next question.
Yeah. So, I think one of the trucks had flipped and slid sideways at 60 miles an hour and hit a concrete wall and never lost vacuum. Aside from that, impacts, many instances of impacts with heavy equipment and other things that have been reported with our equipment that we're aware of, because we have a repair shop as well. And we rarely see any significant damage to the outer vessel. If you use a large enough caliber, you could probably get through. But
no explosion. Explosion. Yeah,
right.
Yeah. That's a good point. Adam's talking about penetration to the vessel. As far as LNG, you could put liquid natural gas in here. A big bucket of LNG and drop a match in there, and the match goes out.
Okay.
Right.
No oxygen.
Because for LNG, it has to be in a gaseous state for it to be combustible.
Liquid natural gas.
Correct. Right. So when it's in liquid form, it's actually
incombustible.
Yeah, correct.
So it needs to be in a certain air-fuel ratio that's a pretty tight band. So the liquid fuel won't burn. You can put a flame right in it. It'll just douse it out. It needs to vaporize and mix with enough oxygen to be in enough fuel to oxygen ratio that it will combust.
Or
with an ignition source.
So are you making equipment where I can literally freeze a man into ice and break him apart? Is that real?
You could do
if
that.
You
could do that tomorrow. If you want to
Good to know. Good to know.
I'm not your guy for that.
Have to make sure the safety manager's off to lunch. But,
so these are on the road. I was incredibly impressed, and I'll let you talk about other projects as well. I was incredibly impressed with a project I saw you guys do. It was a ship that was running off of natural gas. You guys built the internal container, and I guess you built everything, right, for the ship to run off natural gas.
It was a temporary fueling system, basically, for fueling the ship. So they were working on a permanent what they call bunkering, which is basically fueling from shore to ship. So the ship has onboard tanks. They come alongside the dock, and we had a temporary solution that we put in place until they were able to build a fueling facility. So we built it completely at our shop in Applied Cryo in Houston, and delivered it to the port. Went through the entire project with all the authorities having jurisdiction to get all the necessary approvals and permits and so forth, as well as the engineering firm that facilitated that side of it, and
write new code,
and manufactured all the tanks that were going to be used to all the transport tanks, which were the intermodal or ISO tanks that can be transported via land, rail, or sea. So it's just a little more flexible asset in that way. But those were also specifically designed for this project, so they had special connections and everything to integrate with our fueling system.
Yeah, that project was so ACT. It's truly an amazing company. It really is.
This was a custom
to work there.
Job, right?
It was the first. It was the first mobile bunkering solution ever approved by the U.S. Coast Guard for simultaneous operation of fueling the ship and then also loading the ship with cargo. So it was
container ship.
Container ship, yeah.
Now, is that a move that ships are making, or is that just a one-time thing?
Absolutely. Yeah, no, we're seeing definitely more conversions. I mean,
Nice.
they're getting pressure from regulation side as well to improve, and it's a very feasible solution.
When you say improve, you mean specifically improve their emissions. footprint.
Yeah.
They've got to cut it. I should know, but I think it's like cut it by 50% or some they have a very, very ambitious goal by 2000, in the very, very near future. I think by 2030 or, like tomorrow, basically.
Yeah,
so they're,
right.
and you don't just build those things, in a few months. Those types of projects are, have a long cycle to not just start, but obviously finish, which is where ACT came into play in that one particular example where they were going to have their long-term solution in place. So that's where the mobile bunkering project that you referenced came into play. And we actually have one now that we're building for one of our customers out of California, where they go from the Port of Long Beach to Hawaii, back and forth, delivering different types of cargo, where they've got two ships that were actually manufactured in Brownsville that are powered off natural gas. So,
well, I think I mentioned that to you in the past.
And then we have the bunkering on the Great Lakes we'll mention here in a moment.
Yeah, that's, then that kind of coincides with my question. Number one, I want to know what you guys expand on what's coming. Like what you got, what are you guys working on that's really cool, that's coming up? And, the Great Lakes thing, I kind of know what it is, but of course you're going to explain it. I've always thought that the islands were the perfect customer for this. And I mean the Caribbean islands, because
definitely.
I had a friend, I spent a lot of time in Jamaica. Power and fuel is incredibly expensive and hard to get there. And a solution there, a long-term solution there is that's a bold agenda for ACT, but it's an agenda. It might be, but
it is, and it's definitely a market for us. There's some big players out there that are pretty heavily into it. They have been for probably about 10 years or so. And definitely everybody recognizes the opportunity, and it does work out. I mean, we have found good ways to bring cheap fuel and power to these places. So it is much more on the small scale, and that's where we've kind of found a lot more opportunity to bring LNG into places where it doesn't exist yet. Because and I'm sure it will go the same way with hydrogen. Everybody's hesitant to make the decision, so you try to make it as easy as possible, right? You line up financing.
Is hydrogen cleaner than natural gas?
Oh, it's
that's a bit of a loaded question, but yes, I think in the end it will be.
Right. Yeah. It is. It's pitched as zero emissions, right? When you put hydrogen in a fuel cell electric vehicle, what comes out the tailpipe? Water, no emissions. But how did you make the nitrogen? How did you liquefy the nitrogen? So that's what Adam's referring to in terms of a loaded question. But ultimately, that's why everybody is headed that direction, because it is zero emissions.
At the point of the end user, it's zero emission, right?
Right. So current what I mean when I say that is currently majority of the hydrogen produced is used with a process called steam methane reforming. And basically they take natural gas, which is a fuel, and they spend more energy to turn it into another fuel, which is hydrogen. So that's most of the hydrogen in the world. That's the cheapest way to manufacture it currently. The sustainable and zero emission way is to use pure electricity, only electrolysis. So basically, you're running a battery in reverse, right? You're putting electricity to something that is basically causing water molecules to split off and create hydrogen gas for you. So it's very inefficient and energy intensive, and they're working on those technologies to improve them. But currently, because of the economics, and without enough subsidies, that technology is still kind of in its infancy. So the steam methane reforming is why it gets a bit of a black eye, and whatever the energy grid is made up of, right? So if it's a 25% coal, 25% nuclear, that's what the energy that's going in to make that fuel is. And because hydrogen is one of the coldest cryogens at minus 425 degrees Fahrenheit in its liquid state, it's one of the most energy intensive to liquefy.
So the Great Lakes project, tell us a little bit about that.
Yeah, so that was just one of several others that we've done. A little bit of a smaller project in that it's maybe smaller ships, so not as much fuel is being transferred. So it's not a huge manifold with a bunch of pumps on it, like we had done at this other project and these other two projects in California and Florida. So the Great Lakes one, it's a little bit more along the lines of our mobile solutions, where it's a mobile storage unit or a transport trailer even that can haul liquid converted in a special way to be able to do this bunkering or ship fueling operation.
Outside of that, do y'all future plans? What are some cool design? I mean, tell me what you got going on for the future.
I mean, that's also a loaded question. The
if you can't speak about
it, I've certainly I know what my top 5 would be. Certainly, one is to obviously maintain what we're currently doing with our customers, supporting our customers, making sure that we have long-term resources and assets in place to make sure we're taking care of our current base. And then Adam and I can be more free to go out there and identify new opportunities within LNG and hydrogen, right? I mean, that's certainly what we're all looking at. We've the hydrogen market is just going absolutely insane. We decided to get into it about 2 years ago, hot and heavy in R&D, and are all in now. Why didn't we get into it 3 years ago? Because of demand. I mean, I'm trying to think what the total production capacity for hydrogen in the U.S. is. It's nothing. It has a chance to grow by 4 times over the next few years. So there's no infrastructure for that, right? I mean, you're having to create customers. You're having to find customers. Storage, transportation, right? ACT is one of, I'll say, 5 hydrogen tank manufacturers globally. Right. So
really, say 5?
Correct.
Wow.
So there are very few.
Why is that? Is it just regulations?
Well, there's been no demand.
Barrier to market entry. Yeah.
It's demand. That for sure. Barrier to market entry, but the demand. That's why we haven't done it. The demand wasn't there. I mean, we could have done it 10 years ago or 9 years ago.
Take a risk.
Right.
But the cost for us or for ACT and our stud engineering team is in the millions of dollars. So what's the ROI on that? So where do we need to spend our money to where we're going to get the greatest and quickest return? And it was not hydrogen 3 years ago. Now it's different, where you've got, it's the president's talking about it, in his speech to Congress. You've got, you Google hydrogen and you can pull up, the Amazons, the Plug Powers, the Home Depots, material handling, for example. There are 40,000 forklifts that are powered by hydrogen, fuel cell electric.
Well, more important than the president mentioning it, what you said earlier, the big money's in it. If the big money's in it, it's really going there.
Yeah, exactly.
I would imagine there's a reason that big money's in it. It doesn't hurt that the president's mentioning it.
Correct.
Right. So it helps.
There's a lot of clues there.
And the Paris Climate Accord. I mean, all these countries are on board with, getting to zero emissions by 2050. that's unfortunately going to be here quicker than probably
It's
any of
pretty
us.
ambitious. Yeah.
Yeah, and
It is ambitious.
regardless of what the money folks understand about the energy landscape. If Warren Buffett decides he's going to get behind it, a bunch of other people are going to jump on that bet, and so you just see this kind of growing conglomerate of an investment pool that is just following that push, and they don't want to miss out. So a lot of it, good intention, investment to improve emissions, reduce emissions, carbon negative, and all of that decarbonization.
Here's a question I'd like to ask you guys. You guys are in advanced technology, right? This is you guys are. I think you said you're working on hydrogen a few years before it was actually a thing, or before it was a serious thing. I'll give you a few seconds to think about it if you need it. But what is a bold idea that you have? It doesn't have to make sense. It doesn't have to be a demand, or it doesn't have to be realistic. But what is something you would do if you could really just do it? What would it be?
I mean, we're doing it. We're doing it right now.
And that's the hydrogen, or is that just?
It's everything what we do. I mean, our boldest ideas we can't say now. Honestly,
Gotcha.
really. But I truly mean it. I'm one of the most fortunate people. We are some of the most fortunate people in the world to love what we do. And to be my son. Carter Lowrey. I'll do and Annalise Lowrey too, my daughter. I can't not name drop her. I'll be in deep, what. But he asks me and he says,
make sure they download the podcast.
That's right. He follows you on Instagram.
Separately.
That's right. Separately, of course. Yeah. But he said, I'm always talking hydrogen, natural gas, hydrogen emissions, and I love it. And he's like, man, wow, were you always so interested in the environment? And I was like, actually, no. I got into manufacturing, and we manufactured for the oil field, and I like manufacturing. I love it, in fact, and then natural gas came into play, and then we started ACT, and then you kind of get into it and you learn about it, and then hydrogen, and we're just such big advocates for those types of technologies, and so it's where you start and where you end up sometimes is completely different, but some of the biggest ideas we have, we're on literally the tip of the spear. You've got customers out there looking for new technologies to take hydrogen to end users. Mm-hmm. The companies that you don't necessarily read about, in the papers, although type it into Google and you'll see exactly what I'm talking about. You can't, multiple companies, trying to use hydrogen and there's no technology there. So for us, we have our hands full into one, go out to understand, what those needs are. Two, to identify whether or not ACT can support those types of projects. And then three, how are we going to execute and take those products to market? So those are big challenges and trying to connect those dots. We talk about it all the time. It's difficult. So
this is a very personal question to me. How viable is a natural gas high-speed rail system?
I'd say that's pretty viable. You talk about bold ideas. That's one that's been in the works for some time. Not necessarily high speed, but definitely doing locomotives. At least 15 years now, and there's a lot of regulatory pushback, kind of keeping that where it's at. But it is moving forward. And as far as high speed, I think that would be great for this country. I think there's a lot of opportunity for rail, and obviously ships, are starting to make the switch over to LNG. Yeah, long haul trucks. It's only natural to see rail take that up as well.
We're in a pretty dynamic place right now in Texas, and in a place and time. It's wild what's going on right now, and I think a high-speed rail system in Texas would be unbelievable. I think almost everyone agrees on that. Being able to do it with the natural gas that we can pull out of the ground here in Texas, improve jobs and all these things. I just think it would be great. Next question I want to ask you guys: is there a place for you in the space industry? He's here.
We're already there.
Okay.
I would think with oxygen and stuff, probably.
LNG as well.
Yeah.
Hydrogen, of course. But really, we're there with nitrogen and the systems that are required to build and launch rockets. We supply equipment. that support that. We've supplied full turnkey systems that are fully automated, with controls as well, that purge lines and different processes that are required again to test the rockets off natural gas. Like they're doing a lot of rocket testing with natural gas. I'm a space nerd. There's a lot of methane on Mars. So that, they're talking about sending stuff ahead of time when they have a manned mission, and then liquefying methane out of the atmosphere to create a fuel source to return, hopefully to Earth.
That's what y'all do.
Did you just volunteer to go to Mars?
I would do it. I would do it. I would. What a way to go out, right?
I mean, that would be pretty epic.
Right. I'd make it back, though, of course.
Of course you would. I was just saying others would not.
Not everyone's going to make it back, Justin. But
Elon said as much.
Stick next to me, and we'll get back here. I promise.
Yeah, well, I'm gonna be here, so you're good.
We'll build spaceships all day. I mean, we've really taken on almost anything, especially in the slow times when we really had to take a hard look at almost anything within our wheelhouse. If I really dug through all our archives and pulled out all the drawings of different things that we came up with, it's pretty impressive.
We have designs for hydrogen spheres for rockets in place. So yeah,
you touched on something I didn't think of though when I asked that question. When I asked that question, I was sincerely thinking about the rocket ship, the actual fuel tanks there. But you touched on sending something there that is literally the movie The Martian. That's what he's trying to do, convert that atmosphere into something usable for himself, right? So that's something I didn't think of. That's pretty interesting.
Well, you saw the Perseverance rover on Mars, the most recent rover that made it. They produced like 10 grams of oxygen or something like that. I might have the amount wrong, but it was the first time ever that we, as the human race, have used resources from another planet for human consumption. So it's that's pretty fascinating. All that is basically air separation. Like the plants that you mentioned earlier there, Adam. But lots of different applications, whether it be for propulsion in space, coming back from Mars, or to get off Earth on the launch pads. You'll see our type of equipment, whether it be pumps, tanks, trailers, spherical fuel tanks for the airborne applications. You'll see ACT's technology all over those examples.
Fantastic. So you guys are, you're building the tanks to transport the cleaner fuel. You're making them safe. You're helping provide a source of energy that's a lot cleaner. And that's what the world's going to. Earlier, offline in our conversation, you still have 200 people working for you. There's skilled welders. There's skilled people in this manufacturing facility.
The best.
This is a safety podcast as well as environmental. Justin had asked you a question about your safety record. I wanted to highlight that because that's amazing. It was. What did you say?
Well, specifically, what I asked about was the experience modifier rate. So that specifically speaks to workers' compensation and severity of incident and severity of injury. And so when I asked that question, and you actually had your rate, which was impressive for a salesperson,
right?
And that's something I would applaud. But what was it?
0.63.
0.63.
Yes, sir.
And that number resonated with me because that's also the number that we have at Wildcat. And from my understanding, that's as low as it can be for the industry classification that you have. And so when you think about the hundreds of thousands of square feet of warehouse that you have, or manufacturing space that you have, the majority of that with overhead crane. And you're not moving like a pallet of bricks. You're moving big, heavy things, right? And you talk about, the attaching of hemispherical heads and all of the stuff that you guys have. That's impressive, man. That's a really, really strong number and speaks to a commitment outside of, the environmental gains that we're picking up from what you guys do inherently, but just a commitment overall to the well-being of your community at ACT.
Yeah, absolutely. And it's I'm the sales guy. I'm the only one that doesn't do anything, right? So it's all it's a testament to the people on the floor. From the welders to the guys that sweep the floor to their production supervisors to their managers all the way to the top. And Adam and I always say everyone's in quality. Everyone's in safety, and everyone's in sales. everyone that works for a company needs to think that way. If they truly love the company and are buying into that. So culture, that's really about culture. And, we Adam and I speak all the time, and Bob Ernle and Jack Smith are my two partners, and so many more speak all the time about culture, and driving the right culture into your employees. And that's all about accountability, and leading by example, and leading with a good example, right? There's certainly some bad examples out there. So it's not all about leading by example, but what is leadership? Leadership to us is setting your standards so damn high and then just striving to achieve your standards and let everybody else watch you do it. And then that just permeates throughout the whether that be ACT or our families or our friend group, or, any environment that you're out there with. And safety is obviously a big part of that. Quality is a big part of that. And, we certainly haven't arrived, right? You're a safety guy, that's just continuous process improvement. And, making sure that when there's near misses out there or injuries, most of ours tend to be, cuts on fingers that we talked about, or something in the eye, some small particulate, and that's all about training, making sure that depending on, what the job function is that you're doing that day, making sure that you've thought through that process, safety in mind first, for project execution. So that's all culturally driven.
That's a great point. And, you guys are obviously in, senior leadership in the company and that. So how does ACT, from your perspective, instill that type of workmanship and culture into that, base level, entry level employee, to ensure that that person understands it just like you guys do?
I want Adam to chime in on this as well, but it kind of goes back to what I said about, setting your own personal standards so high. It's one thing to try to tell somebody to do something, and to throw authority around to get something done. That doesn't last. Something totally different to make someone want to do something for themselves. And influence.
So, taking ownership and really owning responsibilities, owning the quality of work and caring, and if they see you care, then they care. I feel like that's just the contagious aspect of it, and closing the loop, delivering the message, but how are you closing the loop with people if they think you're not going to follow up and, see that they're doing what you asked them to do? So, you do that with yourself, you do that with the people that you're leading, and they want to catch on to that.
Right.
Well, it's evident, obviously, and statistics are one thing, right? And that number is fantastic, but that number doesn't happen by accident. No pun intended, right. Or pun intended, whatever. But that number is a real indicator of culture, and so I'm glad that we get to highlight that, because it is important to understand that that's a great driver of success overall from a business perspective,
right?
In general, so that's a great indicator.
Yeah, thank you.
And of course, the two safety people in the room we're looking for things like that. Thank you guys for coming on. Tim and Adam, this was an enlightening conversation. I actually thought I knew a lot. I didn't really. So I learned a lot in this. The technology you guys have, the future pushing technology that you're doing, you're driving the future. Not a lot of people can do that in their business, and that's a very exciting thing. You're manufacturing here in Houston. What a great thing! Great place to be at a great time. Thank you for coming on and telling us what you're doing and the positive things you're doing in the world. And also, thank you for the safety culture. I appreciate you sharing that. That's awesome. We appreciate that here. Obviously, Justin and I do. So that was a great thing too. How can our listeners learn more about your company?
Yeah, visit us on our website. We'll be at several trade shows coming up. Tim, you have the dates on those. Gada, I think is the most recent one coming up.
We're at appliedcryotech.com. And then, as I mentioned, we've got a Gada show, Gas and Welders Distributors of America, or Association, excuse me. It's been a while since I've been to that show, but that's in Nashville, May 25th. And then June 7th, 8th, and 9th, we are participating in an LNG forum at the DoubleTree here in Houston. And then on the 9th, the LH2 Hydrogen Forum there at the DoubleTree, and we have some speaking engagements and a booth, and it's gonna be lots of fun.
It's great that those are happening again.
Yeah.
After all of the
Yeah.
all of the not happening for the last year and some months.
Yeah,
So it's fantastic to get to have those again.
Yeah, I agree with you.
Well, guys, thanks for taking time away from building incredible things to talk to us. Appreciate it.
Our pleasure. Yeah,
Our pleasure.
Justin and Jeff, thank y'all so much for having us. And again, congrats on a fantastic podcast. And we love what you guys are doing. We love what you're promoting. And we're happy to be a part of it today. Thank you.
Thank you.
Thank you for listening. We hope you enjoyed the show and accept the mission. Please subscribe to the Mission Zero podcast on your preferred streaming service and be sure to give us a 5-star review.